In section 4.3, we are going to look at binomial distributions. I'll post this video on our class page just above this video. If you didn't get a chance to see it, go ahead and play it. So suppose Joe randomly guesses at a true-false statistics question. Joe's experiment has only two outcomes. If a success is guessing correctly, then a failure is guessing incorrectly. Suppose Joe always guesses correctly on any statistics true-false question with probability p equals 0.6. Then the probability of failure is q equals 0.4. This means that for every true-false statistics question Joe answers, his probability of success, p equals 0.6, and his probability of failure, q equals 0.4, remain the same. This experiment is an example of a binomial experiment. Binomial experiments have the following characteristics. There are a fixed number of trials. Okay, think of trials as repetitions of an experiment. The letter n denotes the number of trials. There's only two possible outcomes, called success and failure for each trial. The letter P denotes the probability of a success on one trial, and Q denotes the probability of a failure on one trial. Note that P plus Q equals 1. The n trials are independent and are repeated using identical conditions. The outcomes of a binomial experiment fit a binomial probability distribution. The random variable x equals the number of successes obtained in the n independent trials. The mean, mu, and variance, and the standard deviation for the binomial probability distribution are listed below. We will use a calculator or a website to help us calculate these probabilities. So here's an example. The State Health Board is concerned about the amount of fruit available in school lunches. 48% of schools in the state offer fruit in their lunches every day. This implies that 52% do not. What would a success be in this case? So the success would be a school that offers fruit in their lunch every day. Let's take a look at another example. A trainer is teaching a dolphin to do tricks. The probability that the dolphin successfully performs the trick is 35%. And the probability that the dolphin doesn't perform the trick is 65%. Out of 20 attempts, you find the probability that the dolphin succeeds 12 times. State the probability question mathematically. So we want to know the probability of x equal 12. A fair coin is flipped 15 times. Each flip is independent. What's the probability of getting more than 10 heads? Let x equal the number of heads in 15 flips of a fair coin. X takes on the values 0 through 15. Since the coin is fair, the probability of success is 0.5 and failure is also 0.5. The number of trials is n equals 15, so state the probability question mathematically. We would state that the probability of x is greater than 10. Now let's talk about the notation for the binomial. B equals the binomial probability distribution function. And then we read this as x is a random variable with a binomial distribution. The parameters are n and p, where n is the number of trials and p is the probability of success on each trial. In this example, it's been stated that about 41% of adult workers have a high school diploma but do not pursue any further education. If 20 adult workers are randomly selected, find the probability that at most 12 of them have a high school diploma but did not pursue any further education. How many adult workers do you expect to have a high school diploma but do not pursue any further education. So we're going to let X equal the number of workers who have a high school diploma but do not pursue any further education. So X values are going to be 0 through 20, where N equals 20 and P, the probability of success, is 0.41, and Q is going to be 0.59. So we are going to find the probability of X is less than or equal to 12, and we're going to use a calculator or our computer, and we get 0.9738.